This is an experiment. This is a research study. Actually, I'm the subject, and you guys are giving me feedback. Should we ever do this again? Should we never do this again? Whatever. Okay, so it's not evaluating you, it's evaluating me. Anyway, the handout I gave you is basically focused on how to analyze data, how to choose, how to use an appropriate statistical model to analyze a set of data. How many of you are in the doctoral program? Okay. How many of you are thinking of, or already have a dissertation topic? A couple of you do. 3 of you? Okay, good. How many of you have some ideas about a dissertation topic? I think that covers most of you. Okay. Let's go through this handout, and then we'll try to apply it. This time, this is a handout I literally finished at 5 a.m. And you're the first group I'm trying it with. I'm going to try it with a class of mine on Thursday night and see if it works, and actually use your feedback to clean it up, because one of the things I know, it does have a problem in the way the pages flow. Anyway, if you look at the front, it basically has a list of questions you can ask. Okay, the first one has to do with what kind of data do I have? And then how do I describe the shape of my distribution? What are preferred measures of central tendency and dispersion for the kind of data you have? What kind of correlation coefficient do I have, or am I using? And the correlation coefficients are sort of defined by the data. So you don't really choose what you say, I want Pearson. And what SPSS does is gives you Pearson, but Pearson for different kinds of data gives you a different kind of correlation. I don't know, you know what I'm saying? If you use Pearson on 2 true dichotomies, it's a phi coefficient. If you use Pearson on 2 continuous variables that are linearly related, it's a Pearson R. Okay? And similarly, if you use it on ranked data, it's a Spearman row. So there's some things about talking about or defining the correlation coefficient you're using. Okay, then basic research questions are independent groups significantly different from each other? And when I talk about independent groups, all I'm saying is that different people are in different groups. Then we'll talk about, are related or matched groups significantly different from each other? This is that repeated measure or pre-test, post-test design that a lot of people like to use. And so we've got tables that will address that. Then we talk about power and effect size. Just basically defining the terms, because a lot of the techniques that you'll do on PASW, sometimes I say PASW, and that's what I should be saying. However, occasionally I'll say SPSS. Whenever I say SPSS, I just hit me in the head or something. It should be PASW. They've just changed the name of the program. Then we talk about what you can do to increase your power. Or decrease your power. And we'll just talk about that. Then we talk about what variables or variables in combination are best predictors, and we'll talk about prediction designs. And when we talk about prediction designs, we're also simultaneously, or at the same time, talking about explaining variance. In other words, we're looking at common variance. We're looking at how much variance is explained by certain variables. Then we go to kind of like some of the more sophisticated or the fancier designs, and these are some of we'll talk about what constructs underlie explain variance in a body of data, and we do it either structurally or sequentially. At that point, we'll look at just principal component analysis and factor analysis and path analysis. Okay, so I'd like to just go through these with you for a couple minutes and see if there's any questions that come up and ideas or things that you have in terms of, we all know what we're talking about here. So what kind of data do I have? Well, basic data are going to be nominal, ordinal, interval, and ratio. Everybody understands that, right? Okay. And the term non-parametric, is that new for any of you? Yeah, okay. Non-parametric is an older term, or a term that is used statistically to define data that's ordinal or interval. That's nominal or ordinal. In other words, it's not a real good term because what's a parameter? Okay, we'll talk about. Hi.
Is it nominal or ordinal, or a combination?
It's nominal and ordinal.
So both.
Yeah. And I'll show you there's something. As soon as I answer that, I have to add a caveat. Mm-hmm. The caveat is sometimes people analyze ordinal data as if it were interval data. Okay? So you'll see that, and the rule is usually 7. If you have 7 categories or more, you can always do it. But by convention, it seems like people are now starting to analyze ordinal data with 5 categories and more as if it were interval data. In other words, they'll find a mean for a Likert scale. Everybody know what a Likert scale is? Mm-hmm. Good. So you have a group of people called the population. That's the group you'd like to study if you had unlimited resources. In other words, that's the real group you're interested in. You might be interested in all people who work for a certain company, or all people involved in a certain industry, or people with a certain DSM diagnosis or something like that, or certain kind of couples, or whatever it is. But there's a population out there. You take a subset of that population, it's called a sample, and you want that sample to be a representative part of the population. You plug it over here, and you measure something. All right? The population has parameters. In other words, a parameter is a characteristic of a population. All right? The sample has statistics. All right? The parameters are characteristics of populations. And these are what we show with Greek letters. These are what we show. Now, statistics are characteristics of samples. So this is a characteristic of sample, and this is going to be English letters. This is going to be English letters. I'm sorry for the messy handwriting. So these are going to be English letters. Those are going to be Greek letters. Well, all you're studying is a sample. That's what you got. Okay? And by what statistics is really all about is taking that sample data and applying it to the population. In other words, this is just what you have, but you're really interested in this. You want to make inferences about that, about the population, from what you got here. Okay? So what we do is we look at what a sample statistic does. Let's think of a sample statistic. X bar. X bar is a sample mean, right? Everybody clear with that? Any problems? Well, what's a sample mean do? It does 2 things. It describes the typical or the average person in the sample, and most importantly, for our purposes here, for your dissertation, it also estimates mu. What's mu? Mu is the population mean. So we take sample statistics to describe the sample and estimate the population parameter. Okay? Now, make sense? Everybody okay with that? Yeah, go ahead.
You said that the sample is characteristics of what again?
Sample is representative section, subset of the population. It's the group I actually study. So what it is I take this group out of the population, and some people put a little what they call sampling frame in there. Let's don't worry about that. But you take this subset of the population, and whatever you find out in that sample, you want to generalize and say it really happens in the population. Okay? So, now, the word parameter there refers to a characteristic of a population. Okay? So what do you think non-parametric statistic does? The term refers to statistics that don't have parameters. Well, that's not logical. And it's a term that statisticians have been using for years, but it doesn't make sense. So non-parametric, when I use the term non-parametric, what I'm talking about is nominal and ordinal data. Okay? When we talk about, and you'll see this in PASW, it has a section that asks you about non-parametric analysis. And what that is, those are analyses that you can do with nominal and ordinal data. And we'll hit some of them right in here today. Now, parametric, on the other hand, refers to interval and ratio data. Okay. What they're really getting at here, and this before computers, this was very important. What they're getting at here is that the parametric data are data that has a lot of different numbers at a lot of different places. It's almost like it's continuous. Okay? Whereas the categorical data, which is what nominal and ordinal really is not continuous. And they were saying, and the logic was saying, that, hey, we need continuous data in order for the mean to make sense, in order for the standard deviation to make sense. Okay, give you an example. There are women and men in here, right? Let's say I say every man is a 1, every woman is a 2. And I add up all the 1s and all the 2s and divide by the number of people in the room. What did I just do? I added a bunch of numbers, and I divided by the numbers I added. I found the mean, right? So I come out and say the mean gender in here is 1.74. Does that make any sense? No, it makes absolutely zero sense. It doesn't mean anything. So that's why they separate. There's different statistical processes that you can do with categories than you can do with continuous variables. Got it? All right. You guys understand categorical and continuous? Okay. Now, there's 2 notes down there. If you can do a procedure with nominal data, you can do it with all the other levels. All right? If you can do it with ordinal data, you can do it with interval and ratio data. Okay. Then remember I said earlier that about ordinal data is often analyzed as if it's interval data. And that's just a convention. Strictly speaking, if you're a statistical purist, you don't do it unless you got 7 or more categories. Realistically, people do it at 5 categories. So they find like mean profiles for Likert scales, Likert instruments. Okay, any questions about this table? Okie doke. Anybody? All right. Then let's go to shapes of distributions. Well, I just used very small things. So this is supposed to be a normal curve, a bell-shaped curve. Symmetrical. All symmetrical means is the right side is the mirror image of the left side. So when I'm talking about a symmetrical distribution, okay, this is a symmetrical distribution. In other words, the right side is the mirror image of the left side. Right? Guess what? So is this. So is this. Because if I split it in the middle, well, so the right is the mirror image of the left. So is this. Again, split it in the middle. Now, for a lot of statistical procedures, you need symmetrical data. So all we're looking at is you look at your data, you make a scatter plot, not a scatter plot, make a histogram or bar chart or a line graph and frequency polygon. New toy. All right. Positive skewed, everybody knows about that. If the positive skews, there's more low scores than high scores. You get a positive skew if you're giving a difficult test, for example. If you have a classroom test that's very hard, there's a lot more low scores than high scores. All right? Negative skewed, a lot more high scores than low scores. This is when you have an easy test. Okay, why are these things important, by the way? Why is level of measurement important? Why do we even talk about that? Anybody know why? How many of you guys have gone over it 100 times? Or many times? Any of you heard it several times in a stat class? No? Okay. Level of measurement is important. That was a rhetorical question, I think. You guys got to give me feedback, please. I get autistic real quick and get manicky and bad things happen. So you don't want that to happen. When we talk about level of measurement, the level of measurement determines the statistical techniques you can use. When we talk about distribution shapes, you need to describe your distribution shape in your dissertation, number one. And number two, there's a lot of procedures that are sensitive to the shape of the distribution. For example, if you're correlating two skewed distributions, it's very hard to get linear relationship. And if you're looking like correlation, you have to do other things. You can't just use it as it is. You have to make a data transformation. And that's a whole other topic. I didn't even go into that one here. So we talked positive skewed, negative skewed, rectangular or platykurtic. Everybody know what platykurtic rectangular is? All it is just flat distribution with no peaks. If you look at it, it's multimodal. It's a multimodal distribution. Mode being the high point of any curve. Mesokurtic, we talk about, there's a couple things that we talk about in curves. And they're all related to calculus, basically. But you talk about dispersion, central tendency. You talk about kurtosis, which has to do with the peakedness. And you talk about skewedness. And those are the primary things that define a distribution. And so when you're using PASW, and you calculate descriptive statistics, they'll give you opportunities to calculate them. So you want skewedness to be around 0. Why? What do you think? What if I got a -7? What would it be for my skewedness?
You define skewedness, Steve?
Yeah. What skewedness is this idea of the kind of the shape of the distribution is asymmetrical. Okay? In this case here, the asymmetry is called a positive asymmetry. So if I gave you a +7 as an index of skewedness, you would see that it was positively skewed. Got it? Okay? Kurtosis, which is another thing you can calculate. And by the way, this is stuff that will impress it'll keep your people, your dissertation committee happy when you describe things this way, because they'll know that you've looked at everything. Kurtosis goes like this. This is leptokurtic. This is platykurtic. And this is mesokurtic. Got it? So it's just talking about the peakedness. Highly peaked, moderately peaked, no peaks. Okay? And most distributions are somewhere between that. Similarly, that most distributions of your sample data will not be perfectly symmetrical, but they'll be symmetrical enough to do things with. Now, do you know why that is? Can anybody guess why that might be? Oh, I forgot my thingy. Well, here's what happens. We're talking about populations, right? And we take samples from the population. In the population, things are normally distributed. But that's not necessarily going to be the case in your sample, because you're not getting everybody from the population. Make sense? So sometimes some of the statistical procedures you look at, it makes assumptions about the population variables, and some of them make assumptions about the sample data. Okay, what truncated means, it just means cut off. If you look at the one there on the bottom of page 4, it says that a truncated distribution, in that case, it was negatively skewed and truncated. This would happen if you have a very, very easy test, and a lot of people get perfect scores. You might see something like this on what's called a criterion reference test. You know, and we've got some kind of moving criteria where you want everybody to get it 100%. Got it? The notes, when you're plotting graphs, the x-axis by convention is going to be the independent variable. The y-axis is going to be the dependent variable. Any questions about that?
Can you repeat that, please?
Sure. The x-axis, this is x, is the independent variable, and the y-axis is the dependent variable. So if I do this, okay, independent variable is the cause, the antecedent. Dependent variable is the effect or the consequence. Right? If I do this, what I'm saying is the shape of the curve is a function of the independent variable. Or I'm saying, in other words, in this case, the shape of that curve is a function of the dependent variable. The value of y depends upon the value of x. Got it? And you can do it like this. Y is equal to a function of x. And so you're saying the value of y depends upon the value of x. Or the dependent variable is a function of the independent variable. Okay? And that's our basic idea of drawing graphs. And the statistical models are basically, are for the most part, based on this function.
Earlier in this section right there, sir, you were talking about dependent is the effect and the independent is the what?
Cause. Yeah. You think about, you want synonyms for independent variable is cause, antecedent, input. Those are some common synonyms for independent variable. Good, I trip on lint. Common synonyms for the dependent variable are effect, consequence, and output. Okay? So when you see those words, think independent, dependent variable. And it'll pretty much keep you straight. In most cases, those terms will always fit that way. Okie doke? Now, again, this is just some statistical techniques do make assumptions about the shape of the sampling distribution. And then data transformation. Now, what's that all about? Some of you folks in I.O. probably talked about data transformation in your stat classes, have you? Okay, all it means is if you've got a skewed distribution, or you've got a distribution that is hard to analyze for whatever reason, it's very ethical and legit, statistically, to transform the scores to make the distribution more normal. And the kind of transformations you can do is you can find the cosine of the value, or you can find the logarithm of the value, or you can find an exponent of a power of an exponent. There's a lot of ways of converting data that are absolutely legitimate, and PASW will show you how to do it. I don't cover it in here. I was thinking about putting it in, and he said yes, no, yes, no. But the only place when I used to teach in the I.O. stuff was I covered it. There's a third class in stats. You guys still take it? No?
Measurement?
Yeah. Actually, it was after the measurement class. It went into Structural equation modeling. That stuff. Okay, so it's if you got a real fancy model, talk to a stat consultant or your instructor, or look on the internet and get some good books, because there's things you can do with data that are perfectly legitimate. Some people think that when you transform data, it's cheating. No, you report the transformed value, and then you convert the transformed value back to the original value. Okay, we got all that? I think so. I got to figure out how I'm going through this thing. Any questions? This making any sense? Anybody bored already? Okay. I just want to talk about what's in here. Now, talk about independent groups, significantly different. Okay, there's all kind of things. Depending on the level of the measurement and the kind of variables you have, you can have 7.
Skip 6?
Oh, I skipped 6?
5.
I and 5. That tells you how screwy this is. Oh, okay. All this is data characteristics, central tendency, and dispersion. Okay? In other words, if you have nominal data, you use the mode and the range. Ordinal, the median or the mean, interquartile range, and the standard deviation. You know what the interquartile range is? Yes? No? Anybody? No? It's real quick. This is the median, right? At the median, I got 50% of the cases, right? Okay. I can find another score. It's called P25. 25% below, 75% above, right? Another one over here. P75. 25% above, 75% below. All right? If I subtract P75 minus P25, I have what's called the IQR. So let's say this median is a score of 10. This is a score of 12. This is a score of 8. Okay? So the IQR would be P25 is equal to 10 minus 8. Or pardon me, screwed up. Is equal to 12. IQR. What did I do wrong? Oh, I got too many things out. Would be equal to 12 minus 8, which is 4. Right? Follow that? And that's the... Well, now, what does that stand for? What is that... What does 4 stand for? What is this range, 8 to 12? Well, it's the range of the middle 50% of the people. The middle 50%. In other words, the median is higher, lower. This is the middle 50%. Got it?
Where did 12 come from, Steve?
I just drew it. It's just, I said that this is a score of 8, this is a score of 10, and this is a score of 12. Okay?
No. Now that I understood that part, can you do that again on the P75 minus P25?
Yeah. Okay. You got that the median is 50%, 50%.
So it's 10.
Okay. And that's a score of 10. In other words, at a score of 10, half the people score above 10, half the people score below 10. Okie doke? I find a score. It's easy calculation. We don't want to go through it. It's use an ogive. P25. P25 represents a score at which 25% of the people score below it and 75% of the people score above it. Okie doke? P75, in other words, I have a score of P75. 75% of the people score below it and 25% of the people score above it. So what I'm going to do is I'm going to subtract this number from that number and find this middle range here, which is the mid 50% of the people. In other words, 50% of the people score between a score of 8 and 12 in this diagram.
And that would be 10.
Yeah. And no, that's 8 minus 12. That's a range of...
It's 4, right.
Yeah.
2 plus 8 is the middle, or 2 minus 12 is the middle.
Absolutely perfect. Yep.
What's IQR stand for?
I'm sorry?
What does IQR stand for?
Interquartile range. Okay? Now, the reason you don't talk about it a lot in stats is because statisticians don't use it a lot. Researchers do. Okay? Because a lot of times we work, as researchers, we'll work with ordinal data. Okay, so we'll use it, and sometimes stat teachers don't even cover it. Okay? And then when we have symmetrical parametric data, we're going to find the mean for the measure of central tendency, the typical or average person, and we're going to find the standard deviation for our measure of variance, of variability, of individual differences. Okie doke? Now, if you have asymmetrical interval or ratio data, parametric data, what happens is something very interesting. Okay. The median's always going to be the high point of a curve. Okay? The median's always the mode. Stand back. Slow down. The mode is always the high point of a curve. So this is the high point. This will be the mode. And what happens to the mean gets shifted in the direction of the skew. Okay? So the mean's out here. That's the mean. And the median is between the mode and the median and the mean. I use MDN for the symbol for median. So the question is, and the statistician addressed the question like this: which score is the most descriptive of the typical or average person in that group? The median. I'm sorry?
Could you just repeat again?
I'm sorry?
Repeat again.
Oh, sure. Yeah. In a skewed distribution, and first of all, in all distributions, the mode is the highest point of a curve. Okay? In other words, it's the highest point, and it's that score that has the highest frequency, that score that most people obtain. The mean is the arithmetic average. You add the scores and divide by the number of scores you added. The median is that score that divides the distribution 50% above, 50% below. Everybody okay with that? Now, depending on the measure of central tendency, you have to have some way of describing the amount of individual differences or the amount of dispersion in a curve. In other words, how do I talk about the spread of the curve? All right? When I use the mean as a measure of central tendency, the standard deviation is the preferred measure of central tendency. So when I use the mean, it's the typical or average person. The spread of scores is represented, or the individual differences is represented, or the dispersion is represented, they're all the same thing, by the standard deviation. I calculate a standard deviation. When I use the mode, in other words, the most people are this, the measure of dispersion is the range. Okay? Because all it is, let's think about when we use the mode. If we use the mode for gender, we've got people in this room, right? Mostly women. Okay? So, what's the modal gender?
Female.
Female. Right? Okay. What's the range of scores? What's the range of them? Males to females. That's all I can say. Got it? Make sense? Okay. Now, let's say I find that the average IQ in this room is 148. And I find out that the standard deviation is 16. What's that tell me? Or let's do easy numbers, 10. Mean IQ is 10 of 100. Yeah, mean IQ is 10. Good. Good. Okay, the mean IQ is 148, standard deviation is 10. So, between a score of 138 and 158, what percent of the people do I expect to score in there? Remember? He knows.
50%.
68%. Yeah. Here, let's do this.
Normal distribution.
Yeah.
Why don't you hit the... Here you go.
I'm an old man,
Yeah,
so it takes a long time. And I'm real old. I should have retired a long time ago. I like teaching, though. I really do. It's fun. In here is 68%. All right? If I go out minus 2 standard deviations and up 2 standard deviations, I have 95%. Okay? And what that's just doing, it's just describing the amount of variability, the spread of scores. All right? Because look what I can do here. They both have the same mean. Are they the same distribution? How do they differ? Spread, the amount of individual differences. So it's not sufficient to describe a distribution by just saying central tendency. Could draw another one up here. They all the same? Of course not. So what I need to do is I have to have central tendency as well as dispersion. All right, now let's go back to where we were a few minutes ago. We were talking about when you find the mode, the measure of dispersion is the range. Right? When you find the mean, the measure of dispersion is the standard deviation. Okay? It can be you need to have a mean to find a standard deviation. Okay? When you find the median, the preferred measure of dispersion is the interquartile range. And the interquartile range, abbreviated IQR, is equal to P75 minus P25. In other words, it's the range of the middle 50% of the scores. Okie dokie? You guys are awful quiet. There's a lot of heterogeneity in here in terms of where you guys are at. How many of you guys are real sophisticated in this stuff? One? How many of you guys are kind of like, what's he talking about? Are you? You taking your SATs yet? Have you?
No.
No.
Well, I did my MBA 5 years ago.
Okay. So we're kind of coming at you with a bunch of words.
Yeah, but it's cool though.
Okay. Yeah, so I'll do the best I can. But you guys, if you need something from me, ask. Please ask.
You know the whole thing about we don't know enough to know what we don't know?
Well, if I say Gabashin, did you find a Gabashin statistic?
Can I ask you a question that's not really on topic? Maybe you can answer it?
I'll try.
Okay, I'm doing my dissertation now, and am I going to be going on with a questionnaire? I mean, every dissertation is going to involve this sort of analysis. It's a required part of my dissertation is to go out and get raw data and perform some of this statistical analysis?
Okay. It depends upon your school. The school I'm in MFT. Okay? In the school I'm in, people can do a theoretical dissertation where they don't necessarily have to gather data. They can also do qualitative dissertations, and they can also do case studies. All right? For a variety of reasons, I prefer people to do, my students do empirical dissertations. They gather data. Now, I would say that for the most part, I would say that only about 20% of my students ever do a qualitative dissertation. Most of them do, and I would say another 20% only do purely quantitative dissertation. And I would say the majority, 60%, do mixed methods. And
one of the decisions I'll have to make for my dissertation is whether or not I'm going to do one of these three. Is that a true statement?
You're in SPM?
I'm in Marshall Goldsmith School of Management, yep. DBA, International Finance.
Okay, you're going to have to find out. You're going to have to find out what your department expects. Now, most of the schools, and I don't know. I used to teach in SPM before it was Goldsmith. We used to have an extra stat class. I could tell you then. That was when this was Alliant, by the way, a long time ago. Right now, you'll have to look for a dissertation manual. Now, let me make a suggestion, and I can't be 100% sure. Maybe you can help me with this. But you go into the portal, look at San Diego Life, and see what you have about dissertation manual for Marshall Goldsmith. And it'll usually tell you the exact expectations. In other words, they'll tell you what you need to know. Will they accept it? And some departments, like I taught it at UCLA for a portion of my life. I taught a lot of my life at USC, and they had no theoretical dissertations. Well, in fact, the department I was in wouldn't even accept qualitative dissertations. Everything had to be this way. Okay, so
quantitative,
mm-hmm.
which would involve the student coming up with some sort of questionnaire and standing on a street mall.
I would hope not. Okay, let's just talk real quick about dissertation process. I know this is going to be reviewed for everybody. You start with a research question. That's number one. You start with something that you're curious about, something that you want to find out. You know, you may want to find out in international finance. What would you be interested in finding out? Think of a question just off the top of your head.
Whether or not the GDP of third world countries is going down due to air pollution.
Okay, so you're talking about a causative relationship between air pollution and GDP of third world countries, right? And you're saying, and that's just what you said.
I agree.
That's what you said. Okay, so what you would have to do in that case, you'd have to operationally define a third world country. You'd have to get some index of air pollution. Some way it's measured the same across all countries. And you'd have to have a way of getting an accurate GDP. And then you'd have to you would have to do this probably. They often say that correlation is not causation, but the other part of that is causation is correlation. So what you would have to do is probably do a path analysis and looking at GDP and think of those variables that might influence GDP. Now, I don't think that you can say that air pollution is the most important factor in influencing GDP. Is it? I don't know.
Probably not.
Probably not. I would guess that there's other factors as well, like natural resources and war and what's going on there. So there's a lot of factors. So you identify some of these key factors, and you also include air pollution by this index that you found. And then you measure and see the amount of influence through a path analysis, the amount of influence that air pollution has on GDP in these third world countries. No questionnaires, no surveys, no one going to malls.
You better make sure you can find that kind of data before you...
Yeah, well, that's what I'm saying. That's what I'm saying. So, when people like to do qualitative dissertations, they're great fun, but they take forever. This stuff, we know when it stops. We know when it stops. When it starts and it stops, it's got a fixed start point, a fixed stop point. Hey, you want to be done in 2 years? You want to be done in a year and a half? Let's design it. Let's do it. Goodbye. I'll hit you. Poof. I'm short, so I usually have to go like this for my students.
So a quantitative dissertation is something that you're doing because the data is out there and you know it's out there, and your committee knows it's out there, and they don't expect
Well, you can attempt to collect the data.
Yeah.
It's not out there. It's new knowledge.
See, the question you asked led to retrospective data. In other words, the question you asked didn't require you to go out and collect new data, but it required you to go out and use and identify existing data and find relationships among an existing data set. Got it? Mm-hmm. Okay. Is that helpful what we just did?
Yes.
Yeah.
Somebody else try one.
Well, you mentioned path analysis. What is that?
Okay. Okay.
Good. That's great. I learned more in 5 minutes than I've done in about a year.
I want my spot picked out at North County Mall.
Yeah.
All right. If we do a path analysis, what path analysis involves, it's finding. Okay. How many of you guys have heard correlation is not causation? Okay.
Over and over.
Over and over. Say it again. Correlation is not causation. Okay, so let's close the door and I'll tell you the truth.
Okay.
Now that you're a doctoral student. Now that you're a doctoral student, yeah, correlation in and of itself is not causation. However, all causation is correlation. If I throw a rock and break that window, my throwing the rock is correlated with that window breaking. Got it? So when I have causation, I automatically have correlation. Make sense? So, with path analysis, what are you interested in? Let's see if we could get something for you.
I'm thinking about focusing on restructuring in corporate America with leadership tendencies.
Okay. So, what would your dependent variable be?
Dependent variable.
Consequence, output. If they restructure, then productivity, happiness.
Productivity.
So you want productivity over here.
Can you give us a definition of path analysis and then go into the...
Yeah, but it's going to be easier to show you. Because what it is, if I say it to you this way, it's a structural equation modeling process that identifies the sequences in which independent variables contribute to a dependent variable.
Okay, can you say this?
No.
I see Wikipedia in my future.
Okay. You want to see productivity.
Yeah.
Okay, what are some of the variables you think might increase productivity? Give me one.
Employee satisfaction.
Satisfaction. Okay, so I'm going to put satisfaction up here. What's another one?
Compensation.
Compensation. Okay, and give me one more, just one more.
Well, longevity of employees.
Longevity?
Longevity.
Okay. Now, let me just ask you. Do you think that compensation influences satisfaction?
Yes.
Okay. So we could say that compensation leads to satisfaction, right?
Right.
And that in turn, we can talk about longevity, right? Does longevity maybe just logically related to compensation? The longer you're there, the more you make?
Yeah.
This is a path. A very simple path. Just saying that the longer you're there, the more you make, the more you make, the more satisfied you are, for productivity.
So it's linear.
Well, this is what we just talked about. I just made that linear.
Okay.
Let's take another variable. Let's take a variable, gender. Okay? Gender and productivity. All right? Now, does gender influence longevity?
No.
Okay. Does gender influence compensation?
Yes.
Oh,
As long as we don't admit it, but
it does.
Yeah.
I mean, you get the data, it's there. Okay? So now I've got this coming in. And I could put ethnicity. And I could put something like age. All of these other things. And they're all triggering on this. Could it have something to do with mental health and being a happy person?
Sure.
Gender?
No, just could my productivity have something to do with how healthy I am?
Yes. Yes.
Okay, so health. Well, I can look at health maybe going just directly here. However, I also know that health has something to do with here.
Okay.
See what I'm doing? I'm making a theory. And what I do to validate this theory is I find the correlation among all those variables. Okay? Now that correlation to coefficient, if you think about what correlation is, and we can go back and look at it theoretically, correlation is just talking about common variance. In other words, some of the things that cause individual differences in one variable also cause individual differences in another variable. Got it? Mm-hmm. So I'll look at how these things all correlate with each other, and I'll be able to basically write an equation, make a diagram to show how all these other things influence productivity. And I have what are called external factors. For example, gender, longevity, and probably health. And in the middle, I have compensation and satisfaction. Because all of those are affected by other things. Okay? Make sense?
Yeah.
That's what a path analysis does. Now, I did a very, very crude, quick, off the top of my head design. You want to get a journal article. You want to go to the library and search for an article that says path analysis. And then you'll actually see some pretty pictures and nice things, and it'll show you that way. I don't know what stat book you guys are using now. Anybody using a good stat book that goes into multivariate stats? Okay. And it's covered in sort of an advanced multivariate class, or a multivariate stat book.
Okay.
Okay? Okay. That's very, very interesting. Okay. Yes, and I didn't include it in here. Well, I sort of did. You want to do what's called a discriminant function analysis. And what it is, you want to predict gender. In fact, I have it in here now that I think about that. You can predict gender from other variables. In other words, a study we did a long, long time ago was to figure out what's the best predictor of why a kid might wind up in juvenile hall rather than on probation. Know what the best predictor was? Reading. Reading ability. Kids who knew how to read were much less likely to wind up in juvenile hall than kids who didn't know how to read.
Wow.
Yeah. Okay, who's next? Go.
Looking at groupthink and how that affects whistleblower and communications.
Mm-hmm.
And basically utilizing like integrity as a moderating factor too.
Mm-hmm.
And then so that would qualify as a path analysis too then?
Well, there's a number of ways. Okay, excellent question. I'm giving you one model that will work. There are many others that will work. Now, the reason path analysis probably would not be good for this problem is because you have to find non-whistleblowers. And to find a non-whistleblower, you have to be sure that they were exposed to the situation that was whistleblowable.
Well, I mean, I'm actually surveying someone's intent likelihood. So it's just it's a theoretical. What would you do in this situation?
What would you do in this?
I'm not actually surveying whistleblowers or non-whistleblowers.
Okay, so when you get to the point of survey research or questionnaire research, which this is kind of doing, this is self-report.
Right.
Self-report how I think I would behave. The first thing you have to do is you have to factor out social desirability. Okay? And what you usually do is you put a measure of social desirability into your study and see how well it correlates with that tendency to whistleblow. If it correlates a lot, in other words, statistically significant, then you got to play with it quite a bit and you got to massage the data. And I'll give you my card. You can come out and spend a week with me. But that's...
How much you charge?
I'm kidding.
And he's not.
No. What you have to do is you have to factor out the effect of social desirability. So all you have to do is include another measure of social desirability, recognizing that also whistleblowing is a socially desirable act. And that there's not... that's true. That absolutely true. I stand corrected. It's the issue is that what people say they do and what they do. And that's what you're doing in this case. That's a theory development dissertation. Okay? And the theory development dissertation would involve the survey and then predicting whether or not a person sees themselves as a whistleblower in certain situations. Got it? Who's next? Okay, let's go back to the handout. I'll wear you guys out.
I'm sorry, just
no.
a quick follow-up too. Is there any sort of like scales in particular, or any sort of website that you utilize to find general scale things?
What I use with my students is a book called Fisher and Corcoran, or Corcoran and Fisher. I never remember the order of the authors. It's in the 3rd edition, and it's called Measures for Clinical Practice. It's a 2-volume set, and it has measures for kids, measures for families, measures for... it has a lot of different measures in it. Now, this is more clinical. These are more clinically oriented measures. For I.O., I don't know, but I'm sure there's something out there. Look at Burroughs, look at Test and Print, and those sources of test information. Go online. And by the way, the test catalogs are usually pretty good. They're usually pretty good descriptions, and they do that. So you go to PAR and all the different testing organizations. Okay?
What was the name again?
Fisher and Corcoran. Corcoran and Fisher. I'm not sure the title of the book. Let me give you the title. Measures for Clinical Practice.
Practice.
Yeah, Measures for Clinical Practice by Corcoran and Fisher, or Fisher and Corcoran. They've written. It's in the 3rd edition, and once was one and once was the other, and I'm not sure where they're at now. It's like they flipped a coin and I lost track. Okay? And those are all instruments. The instrument is there. A brief description of the instrument is there. How you cite the instrument is there. The original article there's a reference to the original article. It's really a good book. Yeah. Anyways, I use it a lot. I use it when I teach a number of different classes. Okay? Who's next? I'd much rather do that than go over the handout. All right. Let's go back to the handout. Okay, back to the handout here. And when something comes to you, what are you going to say? Hey, Steve-O, Stop-O. Okay, let's just go look at page 6. I don't think we did that yet. Okay. What 6 talks about is different correlation coefficients. Okay. Now, I'm just going to show you something. What you do with correlation, we have a bunch of points. We have a y variable and an x variable, and each point represents two scores for an individual. In other words, this is that person's x score, and that's their y score, right? So each of these points has got two coordinates. All right? What we do in correlation is we hypothetically draw an ellipse or something around that, and then find the long diagonal of the ellipse. Okay? The correlation coefficient is actually the cosine of that angle that it would make with the x-axis. Okay? So those of you who took trigonometry, finally you figured out what to use the cosine for. All right? It's kind of, yeah, anyway. And what we do is we do what's called product moment process. And the product moment process is we look at people's scores on the two variables, and we try to find, in other words, we try and cross products. Remember that? I don't want to go through the formula. I put it up here to bore you guys. Probably don't remember it anyway. Anyways, most correlation coefficients are cosines, and they're also found as by using this cross product method. Now, if you go back to geometry, remember that you talked about rise to run, and you had a thing that was y was mx plus b. You guys remember that? How many remember?
Barely.
Barely. How come I remember? You got a life. Okay, this is where, that B is where it cuts the y-axis. The M is called the slope of the line. And that slope of the line was change in y with respect to change in x. Okay? That's a correlation coefficient also. And we talk about this as rise, going up, to run. Does that make sense? All of those are different ways of talking about correlation. They all mean the same exact thing. And it's just that, how many of you took analytic geometry, calculus, that stuff? Any of you? One. Yes, a couple of you. Okay. All it is, it's talking about locus of points. Okay? It's explaining where those points lie. Okay. Depending on the type of data you have, the correlation coefficient is going to have a different name. And there's different things you can do with it. So if you have a linear... What do I do now? Anyways, when you do the Pearson R formula, when you use this product moment thing, with ordinal data, you're going to find a Spearman row. When you're going to do it with two true dichotomies. Oh, what's a true dichotomy? What's the difference between a true dichotomy and an artificial dichotomy? Okay. True dichotomies are dichotomies that exist in nature. Okay? I'm sorry? Did I have it there? Good. Sometimes I do things right. Don't count on it, though. Yeah. A true dichotomy exists in nature, like living dead, male, female, things like that. An artificial dichotomy is what typically exists on pass-fail tests. Okay. So many of you in here will be taking a psychology licensing exam, right? Let's say a score of 80 is pass. Get 79, you fail. All right? Now, somebody who gets a pass could have a score of 100, could have a score of 80. They're all the same. Somebody who fails could have a score of 79 or 9. They're all the same. That's an artificial dichotomy. Got it? It's sort of this arbitrary pass-fail. All right. So, if you have... God, am I bad? If you have two artificial dichotomies... Thank you. you find a tetrachoric. Now, tetrachoric is more related to the cosine approach. It's calculated with the cosine approach, but it's the same as the Pearson thing.
What's the Pearson one?
The Pearson R formula is basically it's a cross product. It's sigma x y, and you do it with sigma z of x times z of y. Remember what z scores are? Divided by n, I think. Z scores are standard scores. Try that again. Z scores are standard scores. You know what? I'm too old to be teaching anymore.
Keeps it exciting.
Right. So that's the standard score. Any score minus the mean divided by the standard deviation. Yes?
Okay.
Makes sense. All right. Anyway, that's how we find correlation. I want to take this off because I'm not sure I'm right. I don't know what the denominator is.
I think it's n minus 1.
N minus 1, is it? Yeah, depending on the sample size because it's degrees of freedom. Yeah. Thank you. That's why I erased it though. But you had to make me see it. I was wrong twice. Thanks a lot. I appreciate that.
Maybe people get to remember something from sure.
I probably have a record for saying I don't know in my classes more than any 10 people. All right. Anyways, you got biserial. Okay. When you make an instrument, some of you guys going to make instruments, right? Okay. Let's say you're using dichotomous items, yes, no items. Okay? Or right, wrong. Right? Mm-hmm. Right, wrong. If you use right, wrong, and you consider it a true dichotomy, it would be a point biserial correlation. If you consider it an artificial dichotomy, you consider that the wrong, some of the wrongs are a little bit more right and a little bit more wrong. It would be a biserial correlation. There's a thing called partial correlation. Best way to illustrate partial correlation is like this. You look like a pretty nice guy. Are you? Okay. What's your name?
George.
George? Okay. George, would you go in business with me?
I would.
Good. Okay. George and I are going to start a business. And what we're going to do with our business is we're going to figure out why kids can't read. And we're going to go to the elementary school. Oh, there's a middle school over here. Let's go to the elementary school, though. We'll go to the elementary school over here. And let's see the kindergarten kids. And George and I, we'll measure the kids' shoe size. All right? And we will notice that the kids in kindergarten have real small shoes, and they have real small reading ability. Good idea, George. We go to the first grade. Their shoe size is bigger. Guess what? Their reading ability is better. Second grade, bigger feet, bigger reading scores. Well, we know correlation isn't causation, but we also know Brown said something about that, and he disagreed with everything everybody else said, and you guys just believed me. So, and really it is not. So we're going to say that the reason that kids have trouble reading is their feet aren't big enough. And what we got to do is stretch their feet. So create the George and Steve foot stretcher. Sell it to every parent who wants their kid to read better.
Make a fortune.
Do it an infomercial. Okay. So obviously, you see what I'm saying? That there's a correlation between shoe size and reading ability, right?
There is.
Anybody want to deny that?
No.
But is it causal? No. What's happening here is there's another variable called maturation. And it turns out that shoe size and reading score. God, I'd hate to take a class from me. I'm much better with the old chalkboards, and then they got this get high on smell it. Taught my first stat course in 1965, guys.
Wow.
How many of you guys were born then? Not all of you. And reading, they both happen to be correlated with maturation. Because of that correlation with maturation, it makes it look like they're correlated with each other. Got it? Now, I'm still interested. George, who's my honest partner over here, says, hey, before we go to market, let's really feel if that's going to work. Okay? So what he wants to do is called partial correlation. What partial correlation does is it computes the correlation between shoe size and reading ability, removing the effect of maturation. Got it? So if you remove the effect of maturation, what you got is this. No overlap. And therefore no correlation. See it? That's partial correlation. Multiple correlation. Multiple correlation is just the opposite. You want to find the correlation among a bunch of variables, while you want to see how much a bunch of different variables can explain the variance or the individual differences in some major variable. I use the word individual differences and variance and dispersion synonymous. There's a lot of variables, particularly with young kids, that change very quickly. And those variables, we say those variables are really a function of time. So maturation are those variables that change just as a function of time. As the kid gets older, she gets more muscle coordination. She gets her cognitive stuff works better. Her neurons work better. A lot of stuff changes that makes her better able to function cognitively. At the same time, as her neurons are maturing, so are her feet growing. Got it? Make sense?
Sure.
Good. But
well, I'm just trying to think. You and George started this business.
Yeah.
Your data showed that the shoes and the shoe size and the reading ability had some link to them.
Right.
So you were going to get rich by trying to sell this scheme to get the kids.
The foot stretcher, the Georgian Steve foot.
But you were smart and you figured this maturation thing out first before you invested a lot of money, because there was no causal. But what data gave you that maturation piece to the whole thing?
You have to test it.
Okay. Yeah, you'd have to test it. But just logically. See, this is one of the things you got to remember with this stat stuff. It's got to make sense. It's got to make sense. And if it doesn't make sense, then you're finding a new phenomena. Now, shoe size could be related to reading ability. However, I know lots of people with very big feet who can't read real well. And I know some people with very tiny feet who can read very well. So I'm not willing to say that that's the case. So it's like it could be there. But my other observations, for example, if I go to that middle school right down the hill here, it's not going to hold up anymore. So it's something that happens between kindergarten and 5th grade. Got it? It doesn't happen after 5th grade. Ergo, or therefore, it's something that's unique to these kids at that level. Make sense? Yeah. So all of this stuff we're talking about is really the part of quantitative research that's most fun is the deductive logic. And you start with a theory. Let me just do this for a second. Think of a theory you're interested in. Write down a theory you're interested in. Any theory, I don't care. It could be theory of gambling. I teach a gambling elective, by the way. Go.
In knowledge transfer, I did some research there. In order for the receiver and the teacher and the student.
Right.
Okay. The student has to have trust of the teacher.
Right.
That has trust in the information.
Right.
Find the information valuable, have value, and they have to be cooperative and committed to that knowledge transfer.
Okay.
So I have 4 variables.
Okay.
If I take one of them out, does it still happen?
Okay, what I want you to do, George, I want every one of you to make a very simple theoretically that knowledge transfer is a function of trust. Okay? Got a theory? Can you try one? I'll come back. Got a theory?
The relationship between the poverty and education.
Okay, that poverty, education causes, poor education causes poverty, or poverty causes poor education. It's bidirectional.
Yes.
Okay, got one? Want to try? I'll come back. Got one?
That anxiety is a part of autism.
Anxiety is a part of autism. Okay, got one?
That a major component of addiction is avoidance of bad emotions.
Okay, so that if you're addicted, you're part of your addiction. One of the causes of your addiction is the avoidance of pain. Good. None? Can I come back?
No.
Okay, we're not playing. We're spectators today.
I'm just spectating you.
Yeah, you can spectate well then. Got one?
People learn a new language better at a younger age.
Okay, the younger the age, the better they learn. Go ahead.
That there are many causes to infidelity.
Okay, that infidelity has many roots. Okay, could we say that there's a specific root? You can go with, like George, that lack of trust causes infidelity, or infidelity causes lack of trust? Or could we say that immaturity causes infidelity? Can we take maybe one variable of that many causes? I think just one.
We'll do the trust one.
Trust? Okay.
Lack of trust causes infidelity.
Lack of trust. Okay. We're just doing it as an example.
Okay.
Go.
A component of dissociation would be related to trauma.
Trauma and dissociation. Okay, so that trauma leads to dissociation.
The relationship between company and supplier, if the supplier also use the green energy, will motivate the company to have the green energy.
Okay, so that the greater the green energy of the suppliers, the greater the green of the company.
Yeah.
Perfect.
The longer somebody's in grad school, the more stressful the experience will be.
Graduate school and stress. Okay. What about me?
An increase in job satisfaction equals an increase in productivity.
Okay.
Oh man, I'm drawing a blank. The longer someone is an investor, the more risk they'll take.
Okay, so that risk is related to longevity in investing.
Yes.
Okay.
The relationship between organizational manager's mindset and organizational culture.
So the organizational culture is effective is a function of management attitude. Okay. Now, look at your theory and see if you can figure out which was the IV and which is the DV. Which is the independent variable? Which is the dependent variable? Everybody got the IV and DV? Anybody need help? Need help, anybody? Okay. Now, I want you to figure out right now, For your DV, for your dependent variable, what is some way that you could measure it? It could be a test score, it could be an observation, it could be a self-report, it could be something like that. For your dependent variable, you want to figure out a way to measure it.
For which variable?
The dependent.
Dependent?
Yeah, the outcome. This is making for good tape.
And so we're measuring the dependent variable.
Yeah, you want to figure out a way to measure the dependent variable. And this is a crucial part of doing research and doing dissertation and doing studies, is figuring out how you're going to measure that construct. And that's exactly what operationalism is all about. How are you going to measure that construct? How are you going to measure that thing that you think is going to change because of the independent variable? Okie doke. Who's got one ready to talk for a bit? What's your independent? What's it? Okay, I'm going to ask this two ways. One is, what is it conceptually? And then what is it operationally? In other words, how do you define it as a concept, and then how do you measure it? Can you give me your DV?
Productivity.
Productivity is the DV.
Mm-hmm.
And?
It could be measured by performance appraisal scores.
And performance appraisal scores are operational definition of productivity. Perfect.
Okay.
Who wants to go next? Go.
My DV is anxiety.
Mm-hmm.
And it can be measured by meeting criteria in the DSM, or also by anxiety measures like
BDI.
Mm-hmm.
Okay. So the reason that the DSM is probably not a good criterion for operational is that it's still judgment. Mm-hmm. And there's generalized anxiety, and there's 9 different anxieties. So you want to go with something that you can probably not be as subjective.
I have one.
Do you?
ADIS.
Okay, good. Somebody else? Go.
The dependent variables high school graduate rates.
Mm-hmm.
And the independent is per capita income.
Property income and high school graduation rate. Really just count how many graduate.
Good.
Yeah, perfect. Income. How are you going to measure that? And you notice what he's got here, he's talking about a perfect situation. Prediction being as income goes up, graduation rates goes up. Right? Who's out? Who else?
Is there a clinical student that can help me with a stress score? Any sort of stress
yeah, state rate.
Okay.
Yes,
That'd
state
be my
rate.
DV.
Anybody mind? No. State rate's a good instrument.
That'd be my DV?
Yeah.
Life of time.
Okay. Now. Okay, anybody else want to go?
I have a hard one.
Go for it.
A hard one that can be challenged, I guess. And using the knowledge transfer and trust, DV is knowledge transfer, and the IV is the trust. And I'm trying to measure the acceptance of the sustainable success. I'm going to measure it through sustainable success factors. I have to establish the success factors. And what I'm trying to do is that if in order to have to managing change, you have to have knowledge transfer. You have to teach people about sustainability.
Okay, and there's a difference between teaching and learning.
Yes.
That the knowledge transfer is when they're learned, not when you taught it.
Right.
Yeah, good point. You guys have got some really good things here. All right, those of you who didn't say anything, too, you can do this. Figure out a situation that you could use to test the validity of, first of all, make it a hypothesis. If the independent variable, like we did here, if the independent variable goes up or goes down or changes some way, the dependent variable changes or goes up or goes down some way. Okay? Thank you, those of you who...
I have a question.
Yes, sir.
Is it common to be confused as to which one is the IV and which one is the DV? Or is it the one you choose? Do you have control over that?
Well, they are often interchangeable, but they may not be. The key thing is, and this again is logic, if the independent variable is the cause, then it needs to precede the effect. You can't have a past causer. In other words, the future doesn't cause the present causes something now or in the future. Does that make sense? And that's just a logical statement. Well, what about I want to get an A in this class? What's the cause? Wanting to get an A is the cause. Researchers don't lie. Okay. Everybody got a hypothesis? Who wants to jump in with one, just as an example? Somebody. Have I bitten anybody yet?
Based upon those two, based upon our DV and our IV,
okay.
Do we have a hypothesis?
Yeah.
Too?
A hypothesis. What changes? This gentleman here, you got one.
Okay. The longer you've been investing, the more risk you'll take.
Okay. The longer you've been investing, the more risk you'll take. Is that a legitimate hypothesis? Make sense? Okay. Well, how would we test that? Survey.
Longevity of investors.
Okay.
How much risk are they willing to take?
Okay. And so what would we want to know about these investors?
Well, you probably want to draw down investment area.
Would you want to use retired people?
You could, it would have, but they would all be skewed to the long-term investment.
There's probably more fixed. There's more fixed investment than variable investments, than equities.
Yeah.
Okay. So the issue is we'd have to find people people the same age. Why do we have to be the same age?
Population samples.
Because young people generally don't have as much to invest as old people, right?
Yeah, I was thinking about that. I mean, does age matter?
You can't be old unless you can't be.
But longevity
having a lot of
investing, I was thinking is I've invested for 10 years. So whether I started at 20 and continued to 30, or whether I started at 50 and continued to 60, there's still 10 years there.
Well, there's 10 years there, and yeah, you could do that. And if I were your chair, I'd challenge you. And my challenge would be a 20-year-old doesn't think about retirement the same way a 50-year-old does.
Plus, a 20-year-old can take more risk because he has more time to recover.
Exactly. So I would challenge you. So I'd say you need to put age in there as some kind of control.
Enter that into the hypothesis.
Right.
Okay.
So now, for your study, we're going to select people, let's say, that are all in their 30s. See, now another thing that has to be looked at is their state of wealth. Or do you want to use risk tolerance or amount? And how much they invest versus how much risk they're willing to take.
Say that again?
Yeah, there's two ways of measuring this. If I've been investing a long time, by your hypothesis, as I understood it, it was that I'm going to be willing to take more risk if I've been investing a long time than if I haven't been investing a long time.
And I would
yes.
I would argue that if I earned $200,000 a year and only needed $80,000 for substance, that I would have more money to gamble with, so I would take a higher risk because I could accept a higher loss.
So there's a lot. What we're talking about here are called controls. Okay? What we're saying is we have a dependent variable. In this case, it's investment risk. Okay? And we're saying that investment risk is influenced by longevity. That's longevity. I'm not even going to go any farther. Longevity. That's your hypothesis.
We have to define longevity. It's not how old.
How long you've been investing.
Right.
Investment longevity. Okay? But what we're saying, there's other factors that might influence as well. Age, disposable income, wealth, okay.
Knowledge of the market,
yep.
Knowledge of the industry.
What about economic health?
Health status, health insurance, all of these other things. So this is just one of multiple factors. So if we don't somehow control for these, then we're not going to know what this is. So what we do to control for these is we take the same age, we match for wealth, And we match for health status.
How do you establish those controls? Parameters of
okay.
A disposable income of 100,000, age 30
self-reported
to 40.
Yeah. However you want to. And health is a hard one to do. The easiest way to do health is are you in something like Kaiser? People who have good insurance versus people who don't have good insurance. So you may want to just do people who are in Kaiser. Kaiser's a pretty good plan. And so just limit it to people in Kaiser between that age group.
Make an assumption that because you have good health care, you use it.
Yeah, which may or may not be the case. But at least you're not as freaked out about losing money. Okay? Can you hear what we were saying? Okay, let's go through and see. Anybody else have an example of where they would like to test it? How they would like to test their hypothesis? Want to try to? Oh.
This is a good one, yeah.
Yeah. Do you mind?
No, go ahead.
Okay. Let's talk about high school graduation, right? Well, what are some of the things that might affect high school graduation? Obviously, your theory says, and very accurately, poverty, economic status.
Use your magic figure.
See, I get in the light here and I can't see it, so it's like... Okay, so we've got high school grad. And we've got yours, this is the DV, this is the IV, independent variable, and this is going to be poverty level. Okay? In other words, and it's going to be an inverse relationship. What do I mean when I say it's an inverse relationship?
If poverty is up,
poverty is up, graduation rate is down. Right? So, are there other things that affect high school graduation besides poverty?
Quality of schools.
Quality of the schools. Okay, school quality. Something else?
Parents' education.
Well, that would be poverty too.
Okay, that's a structural equation, by the way. Which comes first? Parents' education or poverty and parents' education?
Parents' education, then poverty.
Okay, sure.
No, that's right. No, that's right. Because you could be forced. Your parents didn't get an education.
Therefore.
Therefore you will have poverty because they can't pay for your education.
Okay, so it's which comes first?
Good.
Which comes first? You hear it?
So do you have to test that, or do you just create an assumption?
No. Well,
study it based on the assumption.
You can make that assumption, and all you have to do is ask one question, 2 questions actually: mother's level of education, father's level of education, number of books in your house when you were growing up, and number of books in the house, or something like that. Okay, and then you've got it, and this is going to be called a covariate, huh? What is a covariate? Who wants to guess? I'll guess. Okay. A covariate is a continuous independent variable. It's a continuous independent variable. So when I say covariate, it's a continuous independent variable. What does that mean? That means if I want to control... Well, we should go through ANCOVA in here. If I want to control for that covariate, I measure it, and then I do a statistical process called ANCOVA. Huh? ANCOVA is analysis of covariance. 5 minutes? My alarm didn't go off.
That was very fast.
Steve, you're just falling apart today.
Great class.
So it's okay?
But this is only part 1, right?